So we got a little S&S machining project I'm about to jump on and get started, and what we're going to do is make one of the pins for the parking attachment there. This is the original pin out of the original equipment. It is a 3/4 pin, 3/4 diameter here. This head right here is 7/8, and we got a snap ring groove machined in the end. So today I actually grabbed a couple pieces of material out of our scrap bin at work. One of these is this is a piece of 1045 chrome plated rod. I believe it's 1.25 inches. Yeah, this is a piece of 1.25 inches. This is one that we had to build, and the threads on the end down here where the nut goes they got stripped and galled right there, so we had to make another rod for that particular cylinder. But 1045 is a good all-around steel for making pins and shafts and different things like that. And you know, we have a lot of it around our scrap bin, so I get to grab some of it every now and then and use it to make, you know, for projects. Same thing that I used to make the shaft for the rotary welding table there. That was a piece of 5.5-inch chrome rod that I salvaged to make that shaft. This other one right here, this is a piece of 1-inch tie rod material. This is a tie rod off of a hydraulic cylinder that we just built not long ago, and I don't remember why these were replaced because the threads don't look bad, but I believe all the tie rods were replaced. I think there was a few that got stripped out, so they just replaced them all. And I believe this is 1144 material, but there's a few different grades of stress proof. So in this case, this is more of a mystery metal. But I think today I'm going to go ahead and use the chrome rod, because chrome rod is, with it being smooth on the OD and straight, it's always nice to chuck on this and indicate it, and it holds nice and straight. And like I said, it's a good material to make things out of. So we'll go ahead and use this piece right here. And the only other dimension that I'm going to change on this is I'm going to move the snap ring groove a 1/16 that way. I need to tighten it up just a little bit. It fits fine just the way it is. There's just a little bit more of a gap there between the part and the snap ring groove on mine, the one that I built, versus the original. So that's the only thing we're going to change. So a pretty simple machining job right here. Let's go get started. All right, over here on the Victor, I'm going to use my 4-jaw chuck because it was already set up. I want to show you this. This is one of those filters that I was telling you that I got from a viewer, and we're going to try it out. This is a CPL filter made by Bauer, and this is a housing that is screwed into that fits the GoPro protective housing. And there's another one that comes with this kit also that fits directly on the camera itself. It's round, but they just screw on. Both of them, there's 3 different filters I have. So we're going to try this on the indicator and see if this helps with the glare or not. So just use a 2mm Allen wrench. It's got a set screw on each side, and I usually just snug up one set screw. So we're going to go ahead and put that on right there and snug that up. All right, so the filter is on. So let me grab the material, and I already got these preset to 1.25 inches. And what I want to do is, I need to face this end off, and but I want to hang it out there enough to do this. And I don't like facing with it hanging out that far, that diameter material. So we'll go ahead and just slide it up in there and indicate it and face it, and then we'll pull it back out. This isn't too critical, but it's always good to get practice in, right? It might come in handy one day. So there we go. Let's go ahead and get it faced. I need to set up my tooling, and I'll be right back. So the tool we're going to use, that's a Trigon or a WNMG, and this is a 431 size. I'm using my ISCAR IC8250. This is an insert that I've shown many times. even in my little small videos that I post online of doing some turning. Seems to be a very good insert that is excellent on steel. It's got a good chip formation. It's a TF chip breaker, and I really like it. They don't cost a lot. They're less than $8 a piece, so they're not too expensive. So I have a lot of people ask me about that insert, and I was just trying to throw that out there and let you know what it is, okay? All right, so I'm going to go ahead and we'll slide the bar out now and re-indicate it. We'll just use the pin as sort of a judge on where we want it at. I'm going to turn this back just a little bit further to get some of that material and that chrome out of the way. So I think that's enough right there. A little tip right there is always remember which two you loosen, and you go back to those two. Go back to those same two. All right, so let's get us a little bit more practice in on our indicating here. Never know who's watching, trying to learn. There we go. Looks like a couple tenths. We're ready to roll. So we already got it faced. I'm not worried about refacing it now. We'll go ahead and put a center in it, and then we'll do our turning. All right, I'm going to set my first shoulder length, and that is 4 1/4. So I'm going to use my hook scale hooked on the tip of the tool there, and I'm just looking at the end of the shaft. It's not a supercritical dimension at all, so eyeballing something like this to a scale line should put you within 10 thousandths, and that's going to be close enough. I'm going to use a little mag back indicator here to set me a 0. And there we go. Okay. So we got about a ½ inch to take off of this. I'm not going to try to take any pacemaker size cuts on this machine. We'll take 1/8 of an inch at a time. So you see, that insert works really good for that 1045 steel, and I like the 431 radiuses. It seems to be easier to manage chip control with the smaller radiuses, and whenever you get down to do your final cuts, it's easier to get a better finish with the small radius than the larger radius tools. The one fault that I see with this lathe, something that's always annoyed me, is the gearbox. The speed that I run a lot in is 370, and that's what I was running on the previous cut. The next speed up from 370 is 600 RPM. I think that's way too much of a gap to jump from 370 to 600. There should be a 400, something range, and there should be a 500 range. So now we're running 600 here. All right, we're going to use our calipers just to get a quick reference to see about where I'm at. So 7/8, I'm right on it because I was taking 1/8 passes there. So 7/8, that means I got another 1/8 of an inch to come off, 125 thou. What I'm going to do is I'm going to take 100 thousandths pass and then let this thing cool, and then we'll make our finish passes after it's done cooled down some. I got my Noga Mini Cool over here just helping it cool it down. It won't take but just a couple minutes to get it cooled down like that. Alright, so I've been miking the original pin. This mic here I'm measuring 1 thou under, 0.749. So that's what I'm going to shoot for. Let me see what I got now. That's exactly 25 to come off. And that one, we got about a 1/2 thou taper right there, so we'll see how it does as we sneak up on our size. I'm going to take 15. I'm going to speed it up to 700. I'm going to slow my feed rate down to about 5 thousandths. Readjust the center there. I must have bumped the cross feed handle. I didn't realize it, so I'm going to take a cut and I'm going to measure it. Okay, that's about 15. I'm going to go in another 5. Alright, finish feels pretty good. Alright, so we got 11, we got 12 thousandths there. Okay, and then that one is 11 thousandths. So now I'm getting a thousandths taper, but that's okay. I'll be able to file that and polish it down. So this is the smallest end now. I'm just going to dial in 10 thousandths, and that should leave us a thousandths right there to bring in. Alright, as we approach this shoulder here, what I want to do is stop it, and I'm going to go 5 thousandths past my 0. And just back it out by hand. That way it cleans that shoulder up. I think what I've decided to do is polish this area right here, kind of brighten a little bit, and just leave it 1 1/4 inch diameter. Okay. It looks like I hit right where I wanted. We got a thousandths to come down. A little bit more right here on this end. I don't know if you can see that on camera or not. Well, while we got it up there, let me go ahead and swap tools before we do our polishing, I mean. I think we'll go ahead and cut that snap ring groove while we're doing our turning, and then we'll worry about our finish. Alright, so here's our snap ring that we're going to use. I'm measuring it with the calipers. I'm getting 42 thousandths thick. I've been digging around my high-speed tool bits. Here's one right here that'll work. Either side would work. This side is 54. That side's about the same as the snap ring. So I think I'll use this end right here, and I'll just step it over a few thousandths for clearance. I'm going to use my Armstrong tool bit holder here, and I'll just flip it around and get her lined up. As I mentioned before, the snap ring groove is exactly 4 inches to the shoulder there. I'm going to tighten it up a 1/16. So we're going to move it 3 15/16. So I'll just lay it on the tool like this, butt it up against the shoulder. And that's still going to give me some clearance between the snap ring and the housing of the part there. Okay, there we go. Alrighty, I'm going to slow her down. I think 100 is going to be okay. So what I'm going to do is I'm going to touch off and just take 50 thousandths, and that's right in line as what the original part measures to. Bottom of the groove is like 700. Alright, we got our 0 set. There's our 50 right there. So I'm going to use my little mag back indicator down here. I'm going to set a 0, and let's move it. That was measured about 42. Let's go 8 thousandths. 5, 6, 7, 8 thousandths. And go back into our 50 thousandths. Okay. Alright, I'm going to do a little bit of draw filing. Just trying to get a little bit of that cutting oil off right there. This is an old Johnson file. Still works pretty good. Consistent on 1 thousandths now. Alright, we're getting real close there, so I don't want to take it down too far. I want to try to maintain that good fit that I got. But it's about 1/2 thousandths away from it there. Should be right there. All right. Looking good. Looking good. I got to hit this little area right here just a little bit, but all the rest of it is 1 under. So I'm going to do some more filing to kind of blend this in right here. Let's see. or taper that in just a little bit. I'm going to use a different file here. I'm going to kind of just hand blend a little radius there. I'm going to hit that snap ring groove once. Alright. I'm going to use a parting tool to cut this thing off. But the thing that I hate about chrome plating is trying to part through it. So one thing that you can do is usually take a sharp tool, or say a brazed on tool, anything like that. In this case, I'm going to use a threading tool. I want to come in here. I'm going to make this a 1/4 inch stick, so I'm just going to kind of put my tool about 1/4 inch, and I'm going to undercut it to remove the chrome. Once you get that parting tool up underneath that chrome, it cuts fine, but it usually, you know, it wears the cutting edge of your carbide. So this is the one that I want to use right here. And this is just the head of the pin, nothing critical. I tell you what, one thing I wanted to do real quick, I wanted to polish that, kind of brighten it up a little bit. All right. All right, we'll do it right there. I'll set me a 0. That is why I set a 0 with my indicator here, so we can go right back in. It's just trying to skim that right side, so I'm just kind of feeding it in nice and easy. Must be a touch high because it's not wanting to cut now. So yeah. There it is. So I don't ever like finishing a part with those part off lines like that. It's pretty rare that you get a really good finish on that. Sometimes you do when you got a good insert and everything's just perfect. So I'm going to just make a light face cut on that. And one way you could do that is 3-jaw, 5C collet, but I'm going 4-jaw. I'm just going to chuck this very easy. I'm not going to put a bunch of pressure on it to bite into it. Almost doing it one-handed here, and that's really all I need. This it doesn't really have to be that true for facing, so I'm gonna leave it just there, right where it's at there. And I got a tool here ready to go. Let's get some rip'ems going, some feed, and here we go. I knocked that little tit off there. Sorry. Wrong direction. All right. There we go. Actually, let's hit that with a little emery. We got one pin ready to go. All right, you guys are getting a sneak peek at this before you seen the project video yet. So there's the pin. This is the K&T pin. This is the A-bomb pin. I told you I just wanted a little bit more beef up there on the top. So look at that. I actually kind of like that last little bit right there. You push it in there. That'll keep the pin from rotating in those holes. So here is the rotating arm. There it goes. What do you think about that? All right, well, you'll see this in some future episodes, but we got to build all that. I'll just try to find me some nuts like this right here, 3/4 tin. So we still got to build that, and that's going to go right there. That'll swing around like so. And of course we still got to build this pin too for the back end. Alright, hope y'all enjoyed. Alright, I know you wanted to see the snap ring go in there too. Don't leave you hanging like that, so let's put the snap ring on. Okay, there it is. Nice and snug too. So you see I still had just a little bit of clearance there. Alright, that's it for this week's S&S. I hope you enjoyed.